Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Now, this is a case studies video on the impact of the atmospheric chemistry on air quality and climate change. So, atmospheric chemistry significantly impacts both air quality and climate change with the chemical reactions and pollutants, influencing everything from the ground level to the ozone formation and to global warming. So, air quality it depends upon the pollutant formation, particular matter that is present in the air, and it has the adverse health effects due to the and there is also acid rain. Climate change, the greenhouse gases, there is aerosol effects due to the climate change, and the climate change by increased temperature and changes in the weather pattern. So now this case studies will be explained by the students of CSEA section.
A warm greetings to everyone. I am Dharani S from first year CSEA. Here we are going to discuss about the impact of atmospheric chemistry on air quality and climate change. Atmospheric chemistry plays an vital role in shaping our environment. Chemical reactions in the atmosphere impacts on air quality and climate change. Let's take industrial smog as an example. It is basically produced by burning fossil fuels. It produces carbon dioxide, carbon monoxide, sulfur, and mercury. And agricultural emissions are like nitrous oxide and ammonia forms particulates matters in the air, which affects our respiratory system. There are four key concepts. The first one is air pollutants. In air pollutants, there are greenhouse gases and aerosols. Greenhouse gases, greenhouse will trap and heat and lead to global warming. Aerosols are tiny particles that affects cloud formation and radiation balance. Chemical reactions are the next. In chemical reactions, there are ozone formation and nitrogen oxide. Ozone is both beneficial and harmful. It is beneficial in stratospheric ozone layer and it is harmful in tropospheric ozone layer. In nitrogen, whereas in nitrogen oxide, it is harmful entirely. It is produced by vehicles and power plants and by industries which produces gases. Next, it's over to Achyut.
Hi everyone, I am Achyut from first year CSE department. Let me discuss about the key concepts of air quality that are smoke and particulate matter 2.5. Smoke is a type of air pollution that is a combination of smoke and fog, creating a dense, often toxic haze that reduces visibility and negatively impacts the air quality. Then particulate matter 2.5 is an extremely small and inhalable particle with a diameter of 2.5 micrometers or less, posing significant risk to the lungs and bloodstream. Then let's discuss about the climate change. Radiative forcing, that is not nothing but the impact of greenhouse gases on the Earth's energy balance, and feedback loops that amplify or mitigate the climate effects. Now let us see about the case studies of Los Angeles smog. The Los Angeles smog is a type of air pollution that consists of carbon dioxides, nitrogen oxides, and hydrocarbons. It is contrary to the sulfurous smog or the London smog, and the photochemical smog, which is a brownish gray haze that originates from the exhaust fumes and industrial emissions. The city of Los Angeles is surrounded by mountains, which trap the volatile organic compounds and nitrogen oxides in the valleys where people live and breathe regularly. By the period of the early 1940s, the Los Angeles city had all the ingredients for catastrophic smog events which plagued the city for more than 50 years. The solutions for the Los Angeles smog are controlling emissions using alternate fuels and urban planning. Over to Atish.
Myself, Atish, from the first year CCA department. I'm going to explain about the stratospheric ozone depletion. Now let's explore the impact of chlorofluorocarbons on the ozone layer. These CFCs can deplete the ozone layer, which can slowly rise into the stratosphere. These are broken down into UV radiation, which will release chlorine atoms and react with ozone molecules. Now let's see about a success story, Montreal Protocol, which avoids this depletion. The Montreal Protocol is nothing but which was found in 1987. It's a global agreement to protect the stratospheric ozone layer by phasing out the production and consumption of ozone depletion substances. These substances were commonly used in products such as refrigerators, air conditioners, fire extinguishers, and aerosols. These substances will release CFCs, which will deplete ozone layer. Now, let's see about air pollution in developing countries. Let's analyze the chemical pollutants in densely populated areas first. These pollutant areas in the environment are complex and diverse. These agents are divided into metals and persistent organic pollutants. The metals are nothing but lead, mercury, cadmium, cobalt, and arsenic. These persistent organic pollutants are toxic organic gases, organic pesticides, polychlorinated biphenyls, and paint dyes. The metals are short term and these organic persistent pollutants are long term. So let's see some of the strategies which we use to reduce air pollution in developed countries. To clean energy adoption, public awareness and policy changes. These are the strategies to avoid air pollution. To conclude the session, understanding the atmospheric chemistry is vital for sustainable air quality and climate resistance. Thank you.